Hello and welcome students. So today we are going to perform our next practical, that is a viscosity of a bitumen, mainly a cutback. And for performing this test method, you can refer IS 1206-1978. So according to this code, you can measure the viscosity of tar and the bitumen. We can measure the viscosity of the tar and the bitumen. So for measuring the viscosity of the tar, we need to change the orifice to the 10 mm, and for measuring the viscosity of the cutback, you have to change the orifice to 4 mm. So depending upon whether you are measuring the viscosity of the tar or the cutback, you need to change the orifice. According to this code, we are going to measure the viscosity in terms of time. So what we are going to do? We are going to measure the time required to fill the 50 ml of sample. Either it may be a tar, it may be a cutback. Okay. So for filling the 50 ml of a sample, how much time is required? Depending upon that, we can decide the viscosity, or the viscosity is expressed in terms of seconds. Now what is mean by the viscosity? So viscosity is nothing but a resistance to flow, right? So everybody knows this. Viscosity is a resistance to flow. So every bituminous mix, whatever the bituminous mix that we are preparing, for every bituminous mix, it requires different types of the viscosity. And based on that mix, we need to prepare the bituminous sample. Now, if my bituminous has a very high viscosity, if my bituminous sample, maybe a cutback or a tar, if it has a very high viscosity, then there is a problem of a coating of all the ingredients. So main ingredient is aggregate, so there will be a problem of a coating of the aggregates, and hence my stability values or the mixing will not be proper, and the stability values will not be within a permissible limits, right? On the contrary, if my viscosity is very low, means my bituminous sample is having very high fluidity. So when it has a very high fluidity, what it will do? It will just lubricate. It is going to just lubricate all the samples, that is aggregates, and the binding may not be proper. So I need a specific viscosity. Depending upon what type of the mix I am preparing. Okay. So many times we are using this cutback as a prime coat also. So when we are using the cutback as a prime coat, we need a specific viscosity, right? Because it needs to fill the voids of the system. Okay, that cutback needs to fill the voids of the system, so it should go through the voids and all this stuff. So whenever we are doing any job, depending upon the requirement of the job, the particular sample needs to be used, and to decide that sample, we need to determine the viscosity of the cutback or a tar sample. Okay, so this is my viscometer. This is my very good viscometer, and with the help of this viscometer, we are going to find out the viscosity of the cutback or the tar. So mainly today we are going to perform a practical on a cutback. So there will not be any heating. But if I am using a tar sample, depending upon the type of the tar, whether it is RT1, RT2 or something like RT3 and 4 something, okay, whatever it may be. So depending upon the tar sample, we need to heat that sample. And at that particular temperature, we need to perform the viscosity test. And for that purpose, it has a heating attachment. Okay, for heating the sample, it has a heating attachment. So I can heat the sample and taste the sample. But when I am performing the viscosity test for the tar, I need to use a 10 mm orifice. Okay, I need to use the 10 mm orifice, and first I need to heat the sample. Okay, heat the sample for a specified temperature, above specified temperature. Okay, above specified temperature I need to heat it, and while heating we need to continuously stir it. Okay, continuously stir it, then cool down to the specified temperature, and then we are going to pouring into the cup, and then we are going to measure the time required to fill the 50 ml of sample. Okay, then we are going to measure the time required to fill the 50 ml of sample. Okay, so this procedure is for the tar. So obviously, depending upon the RT1, 2, 3, 4, you need to maintain the temperatures, various temperatures. 35 degree, 40, 45, 55 degree, whatever it may be, the sample, according to the sample, you need to maintain that temperature. But when I am measuring the viscosity of a cutback, okay, I don't need to maintain the temperature. Okay, now we will see about this equipment. So this is my redboard viscometer. Okay, as I told you, this is my heating attachment. With the help of this heating attachment, I can maintain the temperature, required temperature for testing the sample or the taste temperature. Okay, so inside this we can fill with the water. Okay, this we can fill with the water. Now this is my cup. Okay, this is my cup which I am going to fill with by cutback or tar sample, right? So this cup is fitted with the 4 mm orifice. At the bottom of this, cup, it has a 4 mm orifice. So that means this sample or this cup is going to be used for a cutback sample. Okay, this cup is fitted with the 4 mm orifice so that I can use for the cutback sample. Okay, now inside this there is a one attachment. Okay, inside this cup there is a one attachment, and we need to fill the sample up to this attachment or this mark. Okay, the mark is given so that we can fill the sample up to this mark. Okay, and at the center you may find a hole. Okay, can you see this? Okay, so at the center there is a hole, and this is my stopper. Okay, this is my stopper, and I can, with the help of stopper we are going to place exactly on this hole. Okay, exactly on this hole, so that we can stop the flow of the fluid. Okay, and after lifting, the flow will stop, and after placing, the flow will stop. Okay, so for stopping and filling this cup, we need this stopper. Okay, so I am going to fit this. I am going to fit this with the equipment. Okay, this is my stirrer. Okay, this is my stirrer which I am going to fit on this cup. So manually you can rotate. Okay, you can rotate this so that you can maintain the temperature. So this is my stirrer. Okay. So this is a stirrer, and this stirrer has a one attachment. Here I can keep my thermometer to measure the temperature of the surrounding water, and one more thermometer is needed to measure the temperature of tar. Okay, so as I am measuring the viscosity of the cutback, I don't need this thermometer. Okay, I don't need this thermometer right now. So if you are measuring the viscosity of tar, that is RT1 and RT2 or anything, okay, so according to its specified range, we need to maintain the temperature. Okay, now we will perform our experiment. So first we are going to fill this cup to the mark that I have told you. Up to that mark we are going to fill with the cutback. Okay, by placing the first, you need to place this stopper exactly at that orifice, and then fill the sample up to the mark and keep your measuring cylinder. This cylinder should be at least 100 ml. Actually this is 50 ml, but it should be of actually 100 ml. First 20 ml you need to fill with a mineral oil or a soap solution. Okay, soft soap solution you can fill with the soft solution or mineral oil up to 20 ml. And then once my sample reaches at 25 ml, then you can start your stopwatch, and once it fills up to 75 ml, then you can stop your stopwatch. And the time which we will get, that is going to give you the viscosity of the sample. Now why we are adding the mineral oil or the soft soap solution? Because when I am filling with the cutback or the tar, exact measurement is somewhat difficult. So if I am filling with the mineral oil or the soap solution which is lighter than my tar, so obviously it is going to come up. Okay, that will come up and it will help to measure the reading. Okay, it will help us to measure the reading. That's why the mineral oil or a soft solution is used. Okay, so we will start. Okay, I'm taking help of my pistol. Okay, so just keep it tuned. Now we are filling a cup with the sample, and we are going to fill up to the mark. Remember, the stopper is placed at the position. Okay, the stopper is placed at the position, and then the cutback sample is filled. Okay, now the sample is filled up to the mark. Okay, the mark which I have shown you, and I'm going to lift the stopper. Okay, at the same time I'm going to start my stopwatch. Okay, this both things you need to do simultaneously, starting the stopwatch and lifting the stopper. Okay, so just a minute. I have lifted and started my stopwatch, and I'm going to stop once it get filled to the 50 ml mark. Okay. Okay. Now it is filled with the 50 ml. The cylinder is filled with the 50 ml, and the time is around. The time is around 1 minute 34 seconds. That means around 94 seconds. Okay. In the similar fashion, we are going to measure the same sample. Okay, 3 times, and then the mean of these 3 reading we are going to report. Okay, so what we are going to do, we are going to repeat this test 2 times. Okay, first we have done, again we are going to repeat 2 times, and then the mean value of these 3 readings we are going to report as a industrial viscosity of this cutback. Okay, thank you students.